Okay, so thanks everybody for joining and welcome to the event. Tonight's presentation will be by Phil Johnson on clean architecture and mobile apps. I'll let Phil introduce himself. We'll go through the agenda for the evening. So once we've gone through this little short introduction, then I'll let Phil introduce himself and crack right on with his presentation. We'll take a break, as we usually do, for about 10 minutes. Be around about sort of 5 to 8, might be a bit before, might be a bit after. Then the presentation will continue. We'll have 10 minutes for questions and answers, and then we look to be closing at around 8:30 this evening. The meeting rules: to respect each other and their ideas. Please, if you could go on mute during the presentations. If you disagree with what has been said, please just challenge politely at the end of the presentation. These meetings are not for recruitment purposes. There is zero tolerance towards discrimination of any kind, zero tolerance towards violent, dangerous or criminal behaviour. I don't quite know how we can do that virtually, but you never know. Got the next .NET Meetup date will be Tuesday the 17th of August, and it will be part 2 of the Blazor WebAssembly e-commerce website that started at the previous meetup. I will see now, Phil, if it's okay with you, if I try and transfer for you to share.
Slide deck there, and this will stop the other screen sharing. So yeah, so as Graham mentioned earlier, this is my kind of presentation on clean mobile architecture. But as we get into it, it becomes a bit more apparent that actually clean architecture is clean architecture, and mobile is just a detail that is on the outside of that. And this kind of stems from, I was reading quite a lot about clean architecture. Fairly recently moved job to a company that does quite a lot with mobile applications. So I thought it would be an interesting and useful experiment to kind of mix the two up, try doing a mobile application and using a clean architecture approach. So yeah, so I'm Phil Johnson, been in software for around 20 years. Quite a lot of my roles have had a focus on Agile and XP practices, primarily .NET. And I'm currently an engineering manager at Makodo, which is a mobile, well, they're an agency that work in the kind of sports betting, bingo, lottery, casino type of application world. So heavily regulated world. We do web applications and we do mobile applications as well. And this is one of the things with clean architecture approach. It really helps with that reusability between the different front ends. Things we'll be covering in this session. So I'll go into clean architecture fundamentals, have a look at a simple mobile application, just a little example to show how clean architecture can be applied. We'll have a look at future changes. So once we have that application in a clean architecture, how easy is it to make future changes? I'll share a little bit about what I liked and some of the things that I might not have liked too much about the clean architecture approach. And then we'll have time for questions at the end and some discussions as well. So to jump into it, clean architecture fundamentals. So let's have a look at the principles of clean architecture. So clean architecture itself is a book by a guy called Robert C. Martin. Most people have probably heard of him. Might even have read his books, might even have read this one. That is the book on the left. And I would really recommend reading it if you haven't. I'll go into the principles and things at a high level here. This is my understanding from what I was reading, and I would really recommend that everybody has a read of the book. The book starts really by describing what is architecture and what are the goals of architecture. And one of the kind of key things that Robert Martin points out is there are 3 architectural paradigms that were created, invented, discovered, however you want to look at it, between about 50 and 60 years ago. And those 3 architectural paradigms are the paradigms that we still use to this day to write code. So there's been shifts in software and how it's delivered and our kind of user interfaces, the cloud and all that's come around, virtual reality and things. But actually, when we're writing code for these different things, we follow these 3 architectural paradigms. So there's functional programming, object-oriented programming, and structured programming. So what Bob Martin's kind of saying with this is that good architecture doesn't change. The things that change over time haven't sort of influenced what good architecture is. He contrasts design versus architecture. He describes design as being about low-level design, whereas architecture is high-level decisions. Design is about building bricks into rooms. So if you imagine bricks being lines of code, you're building rooms, which are the modules. So in .NET, you're looking at a CS file as the module. And architecture is about building those rooms into buildings. So it's about how do you put those classes and modules and code files into the buildings? How do the buildings connect with each other? How big are the buildings? What's the purpose of each building? In design, we've got the solid design principles. And in architecture, we add 6 more principles to that, which are the component principles. So if you have a look at the goal of architecture, and I think this is quite a powerful kind of statement, Bob Martin says the goal of architecture is to enable a small number of engineers to remain productive on a code base as it grows. It's not a very technical statement for something as technical as architecture, but I think it's a really kind of key statement, this future maintainability of software. And Martin Fowler has an article that he wrote called Design Stamina Hypothesis. In this, he kind of contrasts getting things out quickly to market compared to starting with a good design. You can see there the blue line is getting things out quickly to market, and it does initially. It's great. You get a release out early days, but then quite quickly, things start grinding to a halt and slowing down. And you end up sort of, a couple of years in with managers wondering why they've got a team of maybe 100 developers churning out less features than the initial team was a couple of years before when there was 5 or 6 of them. Whereas on the red line, that's good design. And it's about that consistent maintainability over time. To illustrate this, Bob Martin talks about 2 values of code. He says there are a behavioral value and an architectural value. The behavioral value is about the functionality of the code. That's what the users buy. That's what the business is interested in. And that's the focus of the business. That's what they know. That's what they trade in. The architectural value of the code is about the ability to efficiently make changes for the lifetime of software. And one of the really important things with that is people in the business, and when I talk about the business, I mean the non-technical roles, people outside of engineering, they don't know about that, and they don't, to a degree, they don't care about that until they do care about it. It's once everything's slowed down, then that impact that they feel it. So it's really the responsibility of engineering as a whole, ensure that the business is aware of what needs to be done in order to maintain that architectural value. And arguably the architectural value is more important to business than the behavioral value, because without the architectural value, you can't maintain the application going forwards. So solid design principles, so we'll just go through these in a nutshell. So you've got single responsibility principle, which is essentially there should be one source of change to a module or application, and that source should be an actor or a role or a group of people. So you shouldn't get changes coming from different sources that are different roles, different jobs that require changes to the same code module. Open close principle, your code should be easy to extend, but you shouldn't have to modify existing code to add new features. Liskov substitution principle. So in a nutshell, if you've got a collection of things, it's quite a generic collection like vehicles, you should be able to rattle through that collection, calling the same thing on each of those things and not worry about if it's a car or a van or a motorbike. Interface segregation principle is basically don't force modules to implement or depend on more than they need. So this is break your interfaces down into smaller interfaces. Dependency inversion principle, build details against abstractions, not other details. So build against interfaces in C# world, and depend in direction of stability. I think one of the big things here is it's not just about building against interfaces, it's about where those interfaces are located in your architecture that really inverts the dependency. We've now got component principles. So these are the 6 additional principles when it comes to architecture, and they're grouped into 2 different groups of 3 principles. So we've got the cohesion component principles, and that's really just a fancy way of saying why are things grouped together inside of a component. So you've got reuse equivalence principle, and this just really means that there should be a common theme for things that are in a component. So if you look down at a list of classes, there shouldn't be anything that jumps out as unusual to be in that list. Common closure principle. So this is about grouping things together in components that'll change together for the same reason at the same time. So this is like single responsibility principle for components. And the reason you really want this is because if you have things that are dependent on something that's got a lot of stuff in there, and some of it doesn't really change, and the thing that it's dependent on is the bit that doesn't change. If the bit that does change changes, then that thing will need recompiling as well because of the dependency. And then you've got the common reuse principle. And this is about grouping together things that are going to be used together, like interface segregation for components. And the thing with this is, if anybody uses NPM packages, sometimes they just use one very small thing within this massive package. And it means that if there are vulnerabilities in the rest of the package, then that brings those vulnerabilities into your code base, and it might be something that you're not even wanting to use. Group things together that are going to be used together, that'll change at the same time together, that belong together because of some overarching theme. So as well as the cohesion principles, we've got the coupling component principles. Those are about the relationships between components. Acyclic dependencies principle. You should remove any cyclic dependencies. Basically, if you follow around the dependencies, you should never end up back at the start. And the reason for that is if you have 5 or 6 components and you have a circular dependency, you basically created one huge component. If anything changes in those 5 or 6 components, they all need recompiling and redeploying. You don't know where to start rebuilding things. If there's 6 things that reference each other, where do you start? You've also got stable dependencies principle, and this is about depending in the direction of stability, a bit like the dependency inversion. It's something that's more stable, should be depended on by something that's more volatile. Stable abstractions principle is literally a component should be as abstract as it is stable. So I guess the reasoning behind this is if you have something where every time you make a change, its interface changes, then why bother with the overhead of an interface? You're just going to have to update the interface every time the component changes. So just reference the component directly rather than creating an interface. Sometimes difficult to sort of envision what these things look like. This is what a lot of people call the clean architecture onion, because there's kind of a lot of layers to it. If we look in the middle, entities contain enterprise business rules. We'll get into what all these things are as we get into creating an application with this. But if we come out to the next layer, we've got use cases contain the application business rules. As we get further out, we get into a layer that has controllers, gateways, and presenters, or the interface adapters layer. And then you get out in that green layer on the outside, and that's the details layer. So this is really getting into the details of things. This is the user interfaces, this is the databases, this is any API calls, any inputs and outputs basically go in this layer. Any third-party frameworks and things like that as well would go in this outside layer. So this is frameworks and drivers. What we talk about with when we look at this kind of whole thing, when we look at the middle of that circle, that's your highest level code. We call those the policies. So the entities, the enterprise business rules, those are what we call policies. As we come out and as we get to that outer layer, the green frameworks and drivers layer, we call that the details, and that's the lowest level of code. And it's obviously a gradient level of as you move inwards, you get higher level. As you move outwards, you get low level code. Dependencies always point inwards from lower level code to higher level code. So you would never have, say, the entities referencing something in the details layer or in the use cases layer. Use cases will reference entities. Things in the details layer will reference things in the interface adapters layer, the next layer in. We have architectural boundaries between components. You have kind of like, there's definite architectural boundaries between components in different layers. And what we do when we come to an architectural boundary in clean architecture is we cross the boundary with DTOs, or data transfer objects, which are basically just buckets of data structures. And we use data transfer objects to do that. So the inner layers know nothing about the outer layers. So entities know absolutely nothing about use cases. Use cases know nothing about the interface adapters layer. The interface adapters layer knows nothing about the user interface layers. And all of the dependencies, like I say, kind of point inwards from the outside to the inside. So that's what clean architecture looks like. So let's have a look at implementing something, and we'll see some code and how that ties into that clean architecture onion. So we'll have a look at implementing an application now called Inked Up. Anybody who's into tattoos might hear that and think it's something that will be of interest to them. But yeah, if you're into tattoos, I wouldn't get too excited. The next slide will reveal how rock and roll my lifestyle is. So there's a simple problem to solve, and I'll go into this very quickly because it's the code around this the thing to show. For the rock and roll world of fountain pen collectors, there's a problem to solve really around if you have a pen that's inked up with one ink, if you dip that pen into a different bottle of ink thinking it's the same one, it contaminates that ink, and the inks and pens can be expensive. So yeah, you've got to kind of keep track of which ink is in which pen. It's not a very difficult problem to solve in the real world. Most people just literally make a note in a notepad. For anybody who is more technically adventurous, they often use an Excel spreadsheet. But it's an interesting thing. There's not much to do, so it's quite easy to abstract some of things out and look at creating a software solution. It can be specific to this problem, and it's something that can change over time based on user feedback. So there is a GitHub repo that has this code in, if anyone's interested in checking it out after the session. And I can share these slides as well if anybody's interested, so you can see where that repo is. So where do you start with clean architecture? And the reality is you'll implement this in kind of slices that run across all of the tiers. This is a really small thing, so we've essentially got one slice, I guess. So the first place to start really is starting in the middle with the entities. And entities contain business critical rules and business critical data. And I think of business critical rules, if you think of like a bank, business critical rule might be how they apply, how they calculate a loan, the interest on a loan. The business critical data for that is, what are the values that you need to calculate that? So it could be kind of how much is being loaned, what's the interest rate, and how long is it being loaned for? It's kind of worth saying, entities here, I know kind of in the .NET world, we have entity framework and things. Now, these entities are very different from that type of entity. That type of entity framework that's an input and output. That's basically data. So that would be in the details layer. When we talk about entities here, I kind of think of this as, if you imagine in a bank, like with that loan example, that might be something the bank clerk kind of writes down, and it's a throwaway calculation. They use the same rule to calculate it every time, but they take the value that comes back and they put that into the thing that's persisted, which might be like a loan application form or something. So think of entities as something you literally set data on, you run your rules on them, and you get the value back out. They know nothing about anything else. They're not dependent on anything. And there's no real concept of storage with entities. And this is our first architectural boundary, really, is around entities. So one of the things clean architecture gives us, it gives us this ability to defer decisions. We don't need to decide on anything yet, right? I know I'm playing around and I know this is going to be a mobile app, but in the real world, if I was creating an application, I don't need to decide yet on what the storage will be for this. Don't need to decide on any of the inputs or the outputs or the frameworks that we might use for some of those details. So it makes sense doing this one in a .NET standard library. So if you have a look at a class library for entities, this is what my class library that I kind of created looks like. You can see, if you look at the ink entity on the right-hand side, we've got a couple of business critical data there. On the pen entity, we have some business critical data, and we've also got business critical rule there, which is ink up. That's why I find this a really quite a nice, simple example. We've got some data there, business critical data that's needed to ink up, and You ink a pen up. So yeah, so that's the business critical rule, and that's the business critical data that are on those entities. So we're saying as well for clean architecture, Robert Martin advises that something should kind of scream what the use of the thing is, rather than whether it's a web application or a mobile application or a ASP.NET MVC application. When you look at the code, it should scream of what the thing is. And I think this reminds me of kind of domain-driven design and what the people who practice domain-driven design call the ubiquitous language, where rather than writing code using technical terms for methods and things, you use terms that are the language that would be used by someone who's going to be a user of the application. So ink up is something that, people who use fountain pens would say that they ink a pen up. So it made sense to use that sort of terminology. So this is our inked up onion so far. We've got one thing, and that's the center of the onion. And we've got entities in there, and we've got pen and we've got ink. So if we come out now to the next layer of the onion, we've got use cases. Now, what all that use cases do is they orchestrate entities. So they set the business critical data on the entities. They ask the entities to perform their rules. They might, in a bigger application, they might have several different entities that are involved in the same use case. But use cases essentially orchestrate entities. There is an architectural boundary between use cases and entities. We don't use data transfer objects to cross that boundary because use cases are orchestrating entities, so they need to do things with entities. But outside of use cases, everything that uses a use case needs to call it with data transfer objects that are defined in the use case layer. You never expose entities to lower levels. The big reason for that is if you do, then that entity orchestration will start happening in kind of your detail layer inside of your mobile apps, inside of your web apps, whatever your user interfaces are, calling things on those entities. And as well, if anything needs to change on the entities, it means that it's scattered throughout the application if they give out those entities to the lower levels. That's why we use those DTOs. It encapsulates changes into layers. Details are injected in from the outer layer. And there is some application here of the common reuse principle, where I've segregated out, for the example that I'll show in a second, some of the shared interfaces and DTOs. And I'll talk a little bit more about why I've done that later on, because it'll become more apparent. Use case implementation and the interface for use cases themselves is segregated out from the shared interfaces and DTOs. And we're still deferring decisions here. We're still in .NET Standard. We still haven't decided on any storage, and we've not had to worry about any user inputs or outputs. So this is the DTOs, and you can see here I've created a class library called use cases shared, and these are the DTOs for the pen and the ink. Basically, very similar to the data that's on the entities, but this is what people will need to pass into the use cases, and it's what people will get back out of the use cases if they call them. In the use case of shared DLL, I've got an interface called iStorage. That essentially has the CRUD methods. Now, I've just gone for CRUD terminology here because we're talking about a detail, and anything that implements storage will need to deal with the general CRUD methods. If we move on to the use case class itself, so this is an interface for the use case class, and I call this iPenCollector Interactor. Bob Martin has this kind of this standard, I guess, of calling use case classes interactor. And it's worth saying, Bob, I think Uncle Bob is kind of really good at bringing together and synthesizing different ideas from a multitude of kind of different books and other people, bringing these things together to kind of complement each other in a best practice and adding to them a bit as well. But he didn't necessarily come up with the interactor or a lot of the things that are in this, but he's kind of pulled it together and communicated it really well in his book. But if you have a look at what PenCollector Interactor does, so we need some basic CRUD stuff, but I haven't gone with the CRUD terminology because a pen collector would never say I've created a pen or I've deleted a pen. They might say I've acquired a pen or I've got rid of a pen. And you can see at the top, we've got the ink pen use case. That's the interesting one, which really uses the entities and orchestrates the entities. So if you look at the implementation of pen collector interactor, so you can see on the right-hand side, there's quite a lot of the CRUD stuff. But if you have a look at line 17, where we have the ink pen use case, the things come in as DTOs. We convert them to entities. So we set the business critical data on the entities. We orchestrate the entities. So on that pen entity, we call ink up and we pass it the ink entity. I store that data, but we're not storing the entities here. Remember, we'll store the use case DTOs essentially, because we're not going to give out entities to anything, and we're not going to store entities. So we set data on the entities, the business critical data, we orchestrate them, and then they're kind of thrown away at the end. And we do other things that are going to be specific to an application that we create, which is store it. And you can see over the top, we've got that iStorage interface is being injected in, and that's the storage that we use. It's really interesting, I think, when we talk about dependency inversion as well, because there's two different types of dependency. There's source code dependency. So there's like creating a reference from one component to another. And then there's flow of control dependency. And dependency inversion, basically, for me, is where the flow of control dependency is in a different direction to the source code dependency. So we have a look at the inked up onion now. We've got our use cases there. We've got our two class libraries that we've added to our existing entities class library. We've got use cases shared DLL, which has our DTOs and the iStorage interface. And we've got our implementation of the use cases in the use cases DLL. And it's worth pointing out that wherever we cross over dependency-wise between the layers, we are going inwards. So we're going from use cases to entities when we talk about dependencies. So coming out into the next layer, we have interface adapters. And it feels a bit redundant at this point to have an interface adapter. This is a really small application, right? It is a bit of overkill. And all of these things, as I'll talk about, add a level of maintenance cost. So it depends really at which point you might want to pull some of these things out into separate components. You might want to keep them together, but separated in the same component, separate them by folders or something to make it easy to kind of abstract out if you need to at some point in the future. I've added the interface adapter kind of layer, even though it's a small application, because it kind of shows how those future changes can be made easily as well. So I feel like it's worth the investment in the future. It really just wraps the use cases. We're starting to consider the user interface here a little bit more, not necessarily what type of user interface it'll be, but some things that might be quite general to any user interface that we create, or any input and output, should I say. Again, we're still in .NET Standard. We're still deferring decisions. We still don't need to worry about what the UI is. We don't need to worry about what the storage is. The interface adapters layer will have its own DTOs. And anything that comes into interface adapters, anything that calls interface adapters, will have to provide the information in interface adapter DTOs. And interface adapters will convert those DTOs to use case DTOs in order to interact with the use cases. We never expose use cases to the lowest level detail layer. And again, we don't pass the DTOs from use cases back down to details, because again, if anything changed in use cases, it encapsulates the changes to that use case layer and doesn't scatter the things around the entire system. So we have a look at adapters DLL, which is a .NET Standard class library. We've got our DTOs, and I've put those into the same component here rather than segregating them out. And we'll see why, because there's no need to. But yeah, I've got the pen there and the ink, and these very much do just, they're very similar to the use case DTOs. I'm starting to think about the user interface, though, in the sense of we're probably going to want a display name. So for a pen, we're probably going to want to have the manufacturer and the model, and we probably are going to want to sometimes maybe display that or see it if it's a voice interface with the name of the ink that's in the pen. So we're starting to think about our user interfaces a little bit more, but not what type of user interface is, but more just what we're going to want to make easier across all user interfaces, I guess, is it at this level. We've got our pen collector adapter. which basically is just this is a wrap after pen collector interactor in the use case there. So it does very much just map the same interface, although the DTOs for this are the adapters DTOs, not the use case DTOs. And then if we have a look at pen collector adapter, so you can see if we have a look at something like list pens, so you can see there we're using a pen collector interactor, which is injected into the constructor, which has the storage injected into that. But yeah, on line 47 on the right, the lists pens, you can see there that use the use cases to list the pens, but we convert the use case DTOs to the adapter DTOs before we return them. And if we have a look at our ink pen, which is our main kind of use case, I guess, which maps to our business critical rule, we get the DTOs in as adapter DTOs, we convert them to use case DTOs, and then we call ink pen on our pen collector interactor, which is the use case. So they'll go into the pen collector interactor as the use case DTOs, which will then orchestrate the entities. It returns true, I think, from that. But if it did return a use case DTO from that, we'd have to convert that to an adapter DTO in order to return it. So now our inked up onion looks like this. We've got an adapters .NET standard library. So we've got a component there and it has our DTOs and pen collector adapter in, and that wraps the use cases. And you can see here, this references both, this is dependent on the use cases shared component and the use cases component. So we still didn't need to segregate that out at this point, but it'll become apparent later on why I actually went back and split it out at a later point, and I'll show you why. But again, you can see all the dependencies are pointing inwards there, from the outside inwards, and nothing is being exposed from inner layers to outer layers. So now we get down to details and we've got to make a couple of decisions. One of the things we've got to decide is storage, and the other thing we've got to decide is user interface. In terms of storage, if we just wanted to crack on with the user interface, we could actually just write an in-memory storage or something like that. We're just going to inject it into the use cases via the adapter anyway. These things don't need to be final user interface wise. It could be mobile app, could be web app, could be desktop app, it could be anything else. It could be virtual reality headset, it could be voice or anything. And these things don't need to be final, and they don't need to be exclusive either. So we could have different user interfaces in the details. We could have different storage that we can use that gets injected in. So first thing we need to think about is the storage. Now, because I know I'm intending on implementing a mobile application, it made sense as a first release to look at SQLite storage. Again, .NET Standard library, why wouldn't you use .NET Standard at this point? We don't need to really care about where or why or what or when this code is gonna run, or what's gonna run it. All that the detailed storage layer knows about, all it's dependent on is the use cases shared DLL. And this is why I segregated those things out, because it means that if the use case implementation changes, but the interface and the DTOs don't change, or the storage interface and the DTOs don't change, then the storage component won't need to be recompiled. We encapsulate all the SQLite details inside of the storage component, and we implement iStorage from the use case layer. Inputs and outputs are all with use case DTOs, because the iStorage interface exposes things as use case DTOs. So this is our schema files for our SQLite storage, and you can see here we're starting to get attributes on things. And this is why you would never kind of store entities themselves as well, because you wouldn't want your entities, your high-level policies, to have the details on of which storage framework you're kind of using, or which storage device or whatever. So this is our schema, and we've got the SQLite attributes on it. Those schema files go nowhere basically outside of this storage DLL. All we do is inject in a string, which is the SQLite database location, and then we get the pens in from the use case DTOs. Well, line 94 on the right-hand side, this is retrieve pens. So that's going to pull the pens out of data rather than give out those schema files. It converts them into use case DTOs, and then returns those use case DTOs. And remember, it's the use case that will call this, because this is injected all the way down to the use cases. So this is where our storage component sits, and it references use cases shared DLL. That's why that thing was segregated out. And again, the dependencies go from the outside towards the center. Now we get onto our application. So created a mobile app because that was what I wanted to play around with. This was a Xamarin Forms 5 application. So it starts off with, there's one shared .NET Standard component in a Xamarin Forms 5 application. And this creates an adapter singleton and passes in the database location will be passed into the constructor of this app. From the iOS or Android specific applications, which will then use this, and all of the implementation against the use case, well, against the adapter, is inside of this .NET Standard file. So this injects the storage down into the adapter there rather than interactor, and ultimately into the interactor, which is in the use cases there. And it uses the adapter for all functionality. So all of the pages that are in the mobile applications are implemented in this, and it'll use that adapter for all of the functionality. So this is what that looks like. Very simple kind of app class, and you can see there all it's doing is taking in the string for the database repository, creating a concrete instance of iStorage and passing that into a pen collector adapter, which it will then use throughout the application. Now we get onto our Android or iOS apps, and these are pretty straightforward. So all of the functionality is implemented in that .NET Standard DLL for the mobile app. So these essentially just the main activity for Android will work out where it wants to store the SQLite database, and it'll load that application. So it loads the application, but it passes in that full path and creates an instance of the .NET Shared mobile app. And inkedupmobile.ios is very similar, except it does it in AppDelegate CS. So pretty much exactly the same, but this is the iOS specific part of it. And that's it. So now we've got our first release. So we'll take a break in a second. We'll just talk a little bit about the Inked Up Onion now. So you can see there are some things inside the same layers that reference other things within that same layer. But everything where we cross over the boundaries between layers, all of those dependencies are going inwards from the outer layer to the inner layer. And it's worth saying at this point, at the first release, everything is happening on the mobile phone. Everything is running on the device. The storage and the UI, everything is running on the device. And this brings us pretty much to a logical point to stop for a little break. After the break, we'll spend 10 to 15 minutes kind of just chatting through future changes and some of the pros and cons, I think, of using this approach. Cool. I'd be interested in the end as well, other people's kind of thoughts, and everyone's got different experiences, haven't they, and backgrounds, and worked on different things, and yeah, felt the pain of different approaches and stuff.
I'm itching to see what other people have come up with for this. This is very much a pattern that I've really tried to achieve in our company before, and have just really hit a wall on it. Gone for a n-tiered architecture instead.
Yes. Yeah.
I did do a quick bit of due diligence, look at your blog before this, so I think I know what's coming.
Ah, right. Yeah.
I wonder if you know if you also hit the same hurdles as us. There's like so many goddamn DTOs all over the place and whatnot. But,
yes, yeah. So that's the thing. I think as well, one of the big things is, you've got there's auto conversion kind of frameworks and stuff, isn't there? But to keep it to a clean architecture, any third-party frameworks, you've got to abstract into your own component and expose it in a way that you want to implement against it, and then use that throughout the application. So it kind of defeats the purpose, doesn't it?
Yeah.
It also seems that it highly follows the adapter Gang of Four design principle as well.
Yeah, well, again, it is. I think Uncle Bob's really good at kind of synthesizing these things from different people. I know I'm watching his videos kind of at the minute, actually, which are really good. But he goes, he holds books up at various points. He's going through like his solid principles, and these kind of component principles and stuff. He's unashamed, he's not kind of plagiarized people and kind of hiding that fact or anything. He's very, very kind of transparent about the things that he's pulled from different people and different ideas and things. And I guess that's academia, isn't it? You take those ideas from different people and put them together in a way that complements each other and add a little bit yourself.
I think it's very difficult at this point to come up with anything original. You can only possibly come up with combinations of other people's things, right?
I like he sort of sets out at the start of the book, architecture hasn't really, what's good architecture hasn't really changed in the last 20 years. It is funny. I think there's a lot of things, like that Martin Fowler design stamina hypothesis thing. And there's loads of things like 20, 40 years ago, people were talking about a lot of the problems that we have now. And it's, to some extent, it's like we don't want to listen to them, we want to make our own mistakes. And with the way that technology changes, how could people have the same problems kind of 20, 40 years ago, But
yeah,
it turns out they did.
I stumbled on a book recently. It's a fairly recent read. It's like 3 months old. It's The Fundamentals of Architecture.
All right.
They talk through a history of like how companies go from startup to really going into an architecture mode. So I'm an architect at a company.
Yeah.
And so part of that became like really reading up on that. And every story they were reading of what startups go through to become a company that doesn't get downed by technical debt. It's like, yep, we did that. Like move up a layer, until you eventually end up at what is fundamentally a microservice architecture, where you're sharing as much common code as possible without giving up. You've got code reuse, but also decoupling as much as possible, so you can really release that segment.
Part of that
is time we're just following along.
Yeah, exactly. And I think part of that as well is about being able to develop. And it's not just deploying it separately, it's being able to develop it separately, because that enables them to scale up in terms of number of teams, and different teams just work on different microservices and they're not tripping over each other in the same code base and stuff. It does help.
Yeah.
Cool. Let's get on to the last, it's kind of the second off last section, but we've gone through the majority of it. We've had the pain of building an application. And now let's have a little look at how things might change over time, and how following the clean architecture kind of principles enable us to have that maintainability over time. So I guess the first thing is, this is brilliant, best application I've ever used, but I've got it on one device at the minute. I get a new mobile phone, or I get a second mobile phone, and I realize I've got to put all my data in again. And when I use it and ink up a pen, it doesn't transfer across devices. So I figure, why not move the storage into the cloud? And this is fairly easy to do. So in reality, you would put this in a different DLL. You wouldn't put this in the same DLL as the SQLite one. But yeah, you can create a DynamoDB repository that implements that same iStorage interface. And it's a fairly small change. In Inked Up Mobile, the .NET Standard component of the Xamarin Forms 5 application, basically, instead of passing in the database location, you're probably going to pass in the URL for your AWS kind of DynamoDB. You're probably going to have some configuration around security keys and things like that. And that's literally the only change you would need to make in order to move the storage into the cloud. And you can see here as well, that change is in the outside detail there. And when we talk about things that are most volatile, depending on things that are less volatile or more stable, because all the dependencies point inwards, if we can keep changes into the outer layer, then that makes our life a lot easier. So that's the first change. That's brilliant. Now I've got two devices and all of my data is synced. I can kind of do things on one of my devices and I can see it on the other. But now I've got a problem, because I'm starting to get different. If I create a new version of the application, and one of my devices might update, but I might have the older version running still on the other one. So all of my use cases and things in this are still running on the device. So what I can do is I can create a web API, and it's actually pretty easy to do that. We can reuse all of our existing code this basically now it's almost like two separate systems. If we basically create a web API, which is a RESTful web API project, it now creates the concrete instance of the storage, so the DynamoDB repository, and injects that into the adapter, which we still haven't changed, same adapter, same use cases, same entities, but all of that now is running in the cloud. And the only thing that would be running on the device is the mobile application, and we've had to add in our adapters there an API gateway. And there's probably a reality as well that because the API is an input and output, we would probably have another component in the green layer that the API gateway used that was injected in from the mobile app that would contain the configuration, if you like, for where that web API was. But this is brilliant. We're reusing a lot of stuff. Our code is all running in the cloud with the web API sitting on the front of it. Been minimal changes to the mobile app to do that. And all of the stuff that's running in the cloud is just reused. It's the code that was actually running on the device, the mobile devices, is now running in the cloud. So that's brilliant. So now I'm at a point where actually I've got my devices, but if I'm sitting at my desk, my screen is bigger, my eyes aren't getting any younger or better. I would rather just use my big monitor if I can, if I'm at my desk. So how do we do that? There's a couple of ways you can do that. The first way that I thought about, and the first way, someone mentioned my blog post earlier, the way that I think is still kind of detailed in the blog post is the web app could be the same as the web API DLL. So it can reference the storage, create an instance of that, and the web app can call adapters and things. But I went back and changed that actually because I thought a cleaner way was if the web app used the same API gateway component that the mobile app does, and then everything is going through the web API. Now that is another service call, so it could depend on how quick your kind of infrastructure is as to whether that makes sense. For me, that keeps it cleaner, and it means that if adapters changed, for example, or if use cases shared changed or use cases, the Inked-up web API would need to be recompiled, but the web app wouldn't in this scenario. But if it was done where the web app is doing the same as the web API and is referencing adapters and things, then both the web app and the web API would need to be recompiled. But here you can see everything is just being reused, no changes to existing things. And again, the change we're making is adding something to the details there. So now we've got a web app. You know, I might get like a Google Home device or something, and now I'm kind of going voice crazy. And I want to be able to talk to my Google Home device and tell it to ink a pen up. And what I can do here is fairly simple change to the web API. I can add another endpoint controller in there, which satisfies the format that's required by Google Dialogflow. And then in Google Dialogflow, I can create a chatbot agent and configure it to use that new endpoint. And that new endpoint will literally just use the adapter in the same way as the existing API. And again, we've not had to make any changes to existing code here. Technically, we don't need to add it to the same web API. You know, we could create a new component specific for Dialogflow, and that might be cleaner. But we've added a new endpoint and we've added the Dialogflow, but all of the existing code doesn't need to change. So I guess what are the things that I really like about this approach, and what are the things that were a bit of a pain, or that I think might cause frustrations as an application gets bigger over time. So I really like so easy to add new inputs and outputs. It's really easy to swap things in and out, not just inputs and outputs, but other components. It's easy to change or revert decisions. So if we added, say, the web API and decided actually it was better when things were on the device, it's very easy to change that decision back. You're not making changes that are difficult to revert. The code's really testable. It's very well suited to TDD. And when we talk about kind of test coverage, I would kind of foresee from the testing triangle, things like your entities and your use cases are probably going to have a really high level of test coverage. That would be sort of the testing at the bottom of a triangle. And then as you come further out, your user interface, where it's harder to test and everything, your details are going to have less thing. And again, it's things like the database, the inputs and outputs. Those are the things that you actually inject in testing. So in terms of a testing pyramid, the thick end at the bottom is going to be a high level code, your details, and then as you get out towards the outer layer of the onion, our number of tests as well will probably get less. More changes and additions in the outer layers. So again, it's really important, I think, to appreciate that pretty much all of the changes here were in the outer layer. The only thing that we've added is that API gateway component in next layer in. We're not changing anything towards the middle as we do so much in the outer layer, and all of the dependencies point inward. So the things that are changing most in the outer layer are dependent on things that are changing less. The inner layers didn't change. Direction of dependencies was really good, and third-party dependencies were encapsulated in the outer detail there. I find it easy to find where the code is. Now, I might be biased because I've written this myself. I don't know whether it would be as easy if I was looking at an application using clean architecture written by somebody else. But I felt like it was fairly easy to find where the code was. And I felt like using the terminology like acquires pen or gets rid of pen would make it much easier when you're talking to a pen collector to understand where that was. What did I not like? So we touched on this a little bit in the break for anybody who came back a little bit earlier. Yeah, architectural boundaries are quite expensive to cross in terms of maintenance. In the real world, when you're making a change, often if your functionality is changing or adding features, you're going to be adding things to the entities there, even if you're extending rather than modifying your existing code. You're going to be adding things. Those things are going to have to be updated in DTOs, in use case layers, and as it comes out through all of the layers. There was lots of similar classes in the different layers, all quite similar names. Gets a little bit confusing, and just the cost of that conversion code. One of the things, again, we chatted a little bit about at the break, if you weren't back a little bit earlier, was for things like the conversion code, yes, you can use like an auto conversion third-party framework, but in terms of clean architecture, third-party frameworks need to be encapsulated in the details layer. So you would have to encapsulate any usage of conversion frameworks inside of a component that exposed an interface in the way that you want to implement against conversion code. And then you would use that component injected throughout your code. The same with dependency injection frameworks and things like that. They have to live in one component, and then you just inject things naturally, as you know, just through constructors and things like that through the other layers. And that was the big thing for me. So are there any questions or I guess discussions that be interested in other people's experiences or learnings?
Yeah, I have one. So I'll try and use your example of it to try and push a point. The Pen Collectors Guild has now grown by 100 times, 100-fold.
Yeah.
And now we require a custom support tool to support all this. I wonder if you've got any experience with this. I don't know if you could just pull up your onion again so I can point at stuff. So we have our entities where they're ideally as lean as possible, where they don't include things like audit data. Your pen doesn't include date created and date inked and things like that. But that is really useful for customer support. So when someone calls up, they can say, oh, this thing went wrong. And then your customer support can say, oh, I can see you performed this action at blah, blah, blah. And what you end up with is this dual entity where one of them is really neat, lean and perfect for your outer onion layers, and one which you need for your customer support tool, where it includes all of the audit data. How do you achieve that without either making your one that you use not for the customer support tool unleashed, so it's now fattened up with all this stuff you don't want, without duplicating everything? So the struggle I've had previously is every layer of this now gets doubled, really, as you need to support a customer support tool or something like that.
Yeah, it is a really interesting thing, and I don't know if have you read domain-driven design at all?
I have, and that's all the struggle I have. It's like, how do I get this? I just want a little bit more.
Yeah, it's a similar thing there, isn't it? And the kind of a similar sort of problem that I've seen a lot of examples of. And again, it's it's very different showing these simple examples, isn't it? And then seeing an actual big application. But yeah, the thing that I've sort of seen quite a lot, you've probably come across the same example yourself, is like a book company. They might have like a company that deals with books. They might have bookshops, and then you've got a book warehouse. And it's this thing of keeping those things separate, because a book, what's important for a book to the book shop is kind of, what's the content? Is it in color? Is it a hardback? And things like that. Whereas for the book warehouse, they're interested in how heavy is the book, because that's what's going to matter to shipping. How big is it? Because how many of these things can we get into one box? They genuinely don't care what the content is. They don't care who the author is. All they want is an identifier to identify the thing. There's this concept of accidental duplication, which is fine, but you keep it separate because it's a different thing, or you're using it for a different purpose. I think we've kind of touched on it a little bit in the break about that thing about microservices. To be honest, for me, I think you would possibly have a microservice that has that common stuff in, because like you say, the customer rings up and actually they're talking about something that is this actual thing that's stored in another system, aren't they? And there's overlap between some of the data that you need to store about the stuff, but some of it is different. So for me, I think I would keep the additional storage separate, at least in the initial thing, just in the database itself, like separate tables for the different things. And depending on how big these systems were, or the ability to scale differently as well, isn't it? Because you're going to have less people contacting customer support than you are about for the main kind of system and things like that, I would guess. So yeah, it's a really interesting thing. I actually wonder whether kind of like a replicated data might be useful for that. So for the customer services kind of calls to get that data that's used by the main application as well, maybe that's a kind of replicated database, so it's not even hitting kind of the main database that's used by the main application, but there's a bit of a sync there that gets that common data. So yeah, that's kind of where I'm at. Like I say, I'm probably rehashing some of the learnings and things or readings that you've kind of already come across for that.
It's a difficult problem, isn't it? You either have lots of code reuse or you have perfect decoupling. You can't have both in the same world, can you? And
yes, yeah.
The battle you have there, I suppose.
Yeah, I guess it is this trade-off as well. And one of the things in the Clean Architecture book is this. Those component principles are kind of represented by a triangle, like for each of the groups of three, and each one is on a different side of the triangle. And it says, these things conflict with each other. If you do one perfectly, then you're doing the other two really badly. You're never going to reach perfection, I guess. You're always going to be being dragged away from it, though. And it's kind of like this constant thing of trying to move more towards it rather than being pulled away,
Yeah.
Cool, but great question.
I have another question. Okay, so I wonder what your approach would be to converting an existing architecture to this one. This is your step-by-step guide to convert.
It's an interesting one. The best approach is to do things. Big rewrites is scary. They very often kind of fail. I'm a big fan of that piecemeal approach. So I think it's worth kind of picking some things. And again, if you're going to be rewriting something now, is it worth kind of picking something that you can pull out as a microservice and then architect that in a clean architecture way and use that in the existing application, use that microservice there. I wouldn't want to do a whole rewrite, depending on how big the thing is. I personally would do it piecemeal, whether that's gradually migrating from one app to another and keeping both of them running while you're kind of doing it. And actually you might never hit a point where you've fully migrated the other thing, but you're gradually getting more and more stuff out of it. I would probably go down the microservices approach, to be honest.
Yeah, it's interesting because I thought when we started this, it was going to be opposed to microservices. Actually, this does fit in rather nicely with microservices, I think. So there's no reason why this can't exist in that infrastructure, and the same with an SOA as well. It all just sort of work somehow, which is quite nice.
There's a book by Will Larson, An Elegant Puzzle, Systems of Engineering Management, it's called. And he talks a lot about migrations. there's a lot of good stuff in there. He's actually, if you Google Will Larson and blog, all of that stuff is on his blog, goes back like 2007, but all of that stuff is on his blog. But I find it handy having it kind of in a book format, you know. There's a lot of interesting stuff there. He's worked at a lot of companies that have gone through hyper growth. So I think like Stripe, Uber, a lot of companies like that where, you know, it's been those types of companies where the code base has grown really quickly, and they've had that problem of how do you onboard people quick enough without slowing down the existing staff to get people on board and working on code and getting it there. But yeah, he talks about migrations rather than rewrites. So yeah, that could be an interesting one to look into. Has anyone else got any questions or any thoughts from your own experiences?
I have a question and a statement. This is a question around, is it all right to do this? But obviously on your diagram right there, you've got the storage DLL, I'm guessing, talking almost bypassing the interface layer of the onion architecture here, and then talking directly to the use case shared.
Yep.
Is that all right? Or
So yeah, so it's a really good point. So this is where dependency inversion is really interesting. The reason that the storage needs to reference that is because obviously you've got the iStorage there in the DTOs. Now, pen collector interactor, which is in the use cases layer, has a dependency on some storage being there. And this is where we talk about this dependency is a flow of control. So because pen collector interactor is going to call things on storage, it absolutely needs to tell storage what the structure of data is it's going to pass in and what the structure of data is it's going to get back out. Storage itself is injected down into the use case via the adapter. So it goes from the mobile app, it gets injected into the web API here, won't it? From the web API, it gets injected into the adapter, and then that'll inject it into use cases. But this is where dependency inversion comes in, because we're using dependency injection there. So if use cases DLL literally just had a dependency on storage DLL, so that arrow goes the other way towards storage DLL, it could create a storage thing itself, or it could be injected in, right? But it would be injected in not as an interface that use cases are dependent on. It would be injected in as a concrete instance of it. So we're using dependency injection there, but we're not inverting the dependency. The penny dropped for me here a little bit with what dependency inversion actually is. It's about taking the source code dependency, which component references which component, and making that direction different to the flow of control dependency. So flow of control dependency here is still use cases has a flow of control dependency on storage. There's a point in the code of use cases where you'll hit something where we're going to call things on that storage thing. Now, if we didn't have that interface in the use case layer, if we just say we had it in the details layer, right? So storage is dependent on, storage DLL is dependent on something in the details layer, which has that interface in, then use cases would need to have a source code dependency on that thing that is now in the details layer. And that dependency would be going the wrong direction for this onion layer. So hopefully that explains it. It's a really great question, and it's something that, yeah, I've kind of looked at myself when I first did it, and I've had to, when you say, is it all right? I guess anything in code is all right if you're comfortable with it, you know. As we said, there are trade-offs with everything you do, and I guess it's what are you most comfortable with? But that's the one that I did think about myself quite a lot and helped me, this whole kind of learning experience. I guess that was one of the biggest things, helped me understand that there's two dependencies. There's the source code dependency, and there's a flow of control dependency, and dependency inversion is turning, you know, it's where the source code dependency goes in a different direction to the flow of control dependency.
I suppose the other thing is that, as you said when you started your presentation, you'll end up almost with a circular reference, and the whole thing is one big component rather than being broken down as well.
Yeah, exactly. Yeah, so that is another thing.
So I wonder what your experience is like overall of having newer people come into this sort of architecture. So I think fundamentally the dependency inversion is actually quite a complex thing for new hires specifically to get their head around. I wonder if like, does this cost onboarding? Is there an onboarding fee?
It does. Well, one of the interesting thing with that actually is, and I'll kind of use this in my answer here a little bit. Don't know if you've heard of this guy called Patrick Cure, who's really big in like the lead dev world. And he does some tech lead training that I went on actually earlier this week, and it was really good. But he talks there about as one of the responsibilities of a tech lead is making sure that you onboard people onto your team, and it's about having that that kind of setting the expectations. He laid out the usual forming, storming, norming, transforming type of thing, and he said, you get a team and they go through those initial things and they get to the norming stage, and then you get another new starter and they start at the beginning stage, and it kind of brings everyone else back a little bit as well because they're working out how to work with each other. But he said the best way to onboard is to set out to new starters, what does norming look like? What do you expect from everybody who works on your team? So I think, the onboarding process, I think, is key. But I think it's worth saying I would expect different understanding and different steering of other team members at different levels. So I would expect your tech leads on team should know this stuff hands down and be able to really clearly articulate it and everything. Seniors should be understand kind of the stuff themselves to a good extent, and be able to spot in code reviews and stuff kind of when people are going off track. As you come down, I think you're going to get less understanding because a lot of the understanding comes from experience. One of the things we do at Makoto, really big on kind of like software craftsmanship, the whole clean code, clean architecture stuff. For onboarding, we have a kind of recommended reading list, and when you start, you get the choice of a book. Like I say, I started a couple of months ago, and the book that I chose from the list is the one that Uncle Bob talks a lot in his kind of stuff, which is Refactoring by Martin Fowler. We buy people a book, and their first month with us is basically onboard training. So they read the book that they've chosen, they watch the Uncle Bob videos. We do katas. There are a few websites that have like good katas on. For that first month, people will do like six to 8 katas where it's pairing with an existing experienced engineer. And we follow a test-driven development approach, and it's really about that test-driven development approach, for that stuff. And we gradually ramp up people working, but we have a start date, but we tell our project resourcing group that they won't get them on the start date. They get that person for real work, if you like, to assign to a project a month in, and it's expensive, right? And people can leave, right? They can stay with you for a year, and you've lost kind of that month at the start where you could have got a bit more out of them. But we believe that it gives us that maintainability over time that is important.
Okay.
Yeah, I love talking about this stuff. So if anyone does want to catch up on LinkedIn, just drop me a connection and a message, and more than happy to answer things. They post comments on the meetup group.
Cheers, Phil. I think we'll give you a virtual round of applause. That was a very good presentation, and
that makes it all worthwhile.
Answers in your stride, no problem.
Thank you.
So I'll be posting this video up onto the YouTube channel. Also, all the books and references that Phil gave, I'll also put on there, as well as in the .NET Peterborough on meetup.com as well. Just to finish off, thanks again to Phil. The next .NET Meetup is on the Tuesday, the 17th of August. Thanks, everybody. Have a great evening, and catch you next time. Thanks a lot.
Thank you very much.
Okay.
See you later.
Bye now.